Multi-head attention, the brain of AI story writers. Welcome to the magical world where machines learn to write like Shakespeare. Now, let's look at our memory tip. Memory tip: attention equals focus. Just like you focus on important words while reading. Think about when you're reading, your brain picks out the most important words automatically. Here's our real example. Real example. When you read "the cat sat on it," your brain automatically focuses on cat to predict mat or chair. That's exactly what multi-head attention does. And here's our mission. Today's mission: build an AI that can focus on multiple parts of text simultaneously to write beautiful stories. Today, we're building the brain that makes AI storytelling possible. Multi-head attention, the brain of AI story writers. Welcome to the magical world where machines learn to write like Shakespeare. Now, let's look at our memory tip. Memory tip: attention equals focus. Just like you focus on important words while reading. Think about when you're reading, your brain picks out the most important words automatically. Here's our real example. Real example. When you read "the cat sat on it," your brain automatically focuses on cat to predict mat or chair. That's exactly what multi-head attention does. And here's our mission. Today's mission: build an AI that can focus on multiple parts of text simultaneously to write beautiful stories. Today, we're building the brain that makes AI storytelling possible. The three magic components: Q, K, V. First, query Q. What am I looking for? Like asking, what comes after to be? Second, key K. What's available to look at? All the words in the sentence. Third, value V. The actual information, the meaning of each word. Our restaurant analogy explains. Restaurant analogy. Query equals "I want pizza," your order. Key equals menu items, what's available. Value equals actual food, what you get. The waiter matches your query with menu keys to give you the right value. Remember section. Think. Query asks, key answers, value delivers. These three work together perfectly. Let's see it work. Example with numbers. Here's our complete example. Input: hello world, 0.1, 0.2, 0.3, and 0.4, 0.5, 0.6. Step 1. Create QKV. Q equals 0.2, 0.3, 0.4. What we're looking for. K equals 0.1, 0.2, 0.3. What's available. V equals 0.5, 0.6, 0.7. The actual info. Step 2. Calculate attention score. Score equals Q times K is equal to 0.2 times 0.1 plus 0.3 times 0.2 plus 0.4 times 0.3 is equal to 0.2. Step 3. Apply to value. Output equals score times V equals 0.2 times 0.5, 0.6, 0.7 equals 0.1, 0.12, 0.14. Our magic formula. Magic formula. Attention equals softmax, Q times K times V. Now you see the math behind the magic. Building our multi-head attention class. Let's start by setting up our foundation. The first 3 lines are responsible for importing our essential tools. Import torch. Import torch to NN as NN. Import numpy as NP. This gives us PyTorch for neural networks, the NN module for building layers, and numpy for mathematical operations. Next, we create our multi-head attention class and its initialization method. Here, we're setting up the basic architecture. Class multi-head attention NN module. Def init, self, embed dim, number heads. We pass in 2 key parameters, embed dim, which is our feature size, and number heads, which tells us how many attention heads we want. Then we calculate head dim by dividing embed dim by number heads. On the right side, we're doing a safety check and creating our core components. The assert function ensures our dimensions work perfectly together. Then we create 4 linear transformation layers, 1 each for query, key, value, and output. Each of these takes our embed dim as both input and output size. Our remember tip. Remember, Embed dim divided by number heads equals head dim. 512 divided by 8 is equal to 64. We're building the foundation that will power our AI brain. The forward pass, creating Q, K, V. Now we're getting into the heart of our attention mechanism. The first part is responsible for extracting the input dimensions and creating our three magical components. Def forward self, X. Batch size, seek len, embed dim equals X to shape. Here, we're unpacking the shape of our input tensor to understand what we're working with. Next, we create our queries, keys, and values by passing our input through the linear layers we set up earlier. Q equals self.query X. K equals self.key X. V equals self.value X. Each of these functions transforms our input into a specialized representation. The right side shows us reshaping these for multi-head processing. This is where we split our single attention into multiple parallel attention heads. Q equals Q to view, and then transpose. K equals K dot view, and then transpose. We're using the view function to reshape our tensors, then transpose to rearrange the dimensions for efficient computation. Our explanation box. What's happening? We're splitting our big attention into 8 smaller attentions, each looking at 64 dimensions. This is where our AI starts to develop multiple perspectives. Calculating attention scores. We start by finishing our tensor reshaping. The V tensor gets the same treatment as Q and K. We reshape it and transpose for multi-head processing. Next comes the core attention calculation. This block is responsible for computing how much each word should pay attention to every other word. Scores equals torched, matmul, Q, K to transpose. Scores equals scores slash np sqrt. Self.headDim. Here, we're using matrix multiplication between our queries and keys, then scaling the result by the square root of headDim to prevent the numbers from getting too large. The masking section ensures our model can't cheat by looking at future words. Mask equals torch.try with ones and diagonal 1. This creates a triangular mask that blocks future positions. On the right side, we apply this mask and convert our scores into proper attention weights. Scores, masked fill with negative infinity. Attention weights equals torch softmax scores. The softmax function turns our scores into probabilities that sum to 1. Then we apply these weights to our values. Attended values equals torched matmul attention weights V. Finally, we reshape everything back to combine all our attention heads. Key insight. Key insight. Masking prevents the model from cheating by looking at future words. Our AI brain is learning to focus properly. Complete multi-head attention code. Here's our complete implementation, the full story from start to finish. The setup section imports our tools and establishes our class foundation. Import torch, torched nn as nn, import numpy as np. Class multi-head attention inheriting from nn module. Our initialization method sets up all the parameters and creates our 4 linear transformation layers for query, key, value, and output processing. The forward pass brings everything together in a beautiful sequence. First, we extract input dimensions and create our Q, K, V representations. Then we reshape these tensors for multi-head processing using view and transpose operations. The attention calculation section computes the attention scores through matrix multiplication, applies scaling for numerical stability, and creates our causal mask to prevent future looking. The final processing applies the mask, converts scores to weights using softmax, multiplies these weights with our values, and reshapes everything back to the original dimensions. The last step passes our result through the output linear layer and returns the final attended representation. Final message. Congratulations! You've built the core component that powers GPT models to write like Shakespeare. You've just created the beating heart of modern AI language models. Thank you for learning with us. Subscribe and click the bell icon. Stay updated with our latest AI tutorials and coding adventures. GitHub.